So hello, good afternoon everyone. I am Pratyasha Patnaik, lecturer in computer science at Ganesh Polytechnic, Bhubaneswar. So here we discuss about two address instruction set. Basically this is a part of computer system architecture. In computer system architecture, basically we learn about four instruction set, that is 0 address instruction set, 1 address instruction set, 2 address instruction set and 3 address instruction set. So this 2 address instruction set is basically known as the register addressing set. So in this 2 address instruction set we have 4 parts, like one is opcode, one is destination address, one is source address, and the final one is mode. So this opcode is basically represent the operation that we perform. The destination address is basically represent after the operation the data would present or finally store in the register. Source address is the initial address of the register or initial address of the operand, and mode is the addressing mode that we perform. So basically take an example. So this is one expression, that is a plus b into c plus d. Here we perform the 2 address instruction set. So here we take two registers, that is R1 and R2. Then we take m of something, that is the any memory location. So now we perform the operation one by one. So first we perform move R1 A. Here move is the basically the operation, that is opcode. R1 is the one register and A is the one of the source. So R1 is destination address, A is the source address. So it indicates that the value of A that is stored in the M of A, that will transfer into R1. Then the second operation is R1 and B, means the value in R1 is add with the memory location of B, and then the value is stored in the again in R1. So it is indicated as R1 is equal to R1 plus M of B. So first we perform move operation, that is store the value of the A in R1. Second we perform the addition operation with B, that will store this value that is stored in the R1 with the value stored in the B, and both operation or both value will, after addition operation, that will store in the R1 register. So basically in expression this part will complete. Now we will consider this part. So again R1 to C means the value of M of C or the value of C that is stored in the M of C will transfer into, this is R2. Okay, means we take here two register, and R1, the register of R1 work is completed. Now we take the R2 register, so R2. So M of C is the value of M of C is transferred into R2. Same expression that we performed before, that is R2O plus M of D, means the value which will store in R2, that will addition operation with M of D. Then basically this part is completed and this part is completed. Now the final part is the value of this and the value of this will multiply. So perform multiply operation of R1 and R2. Here we basically do the multiplication operation of the two registers, because this a plus b value will stored in the R1 register and the c plus d value will store in the R2 register. So we perform multiplication of R1 register and R2 register. Then R1 is equal to R1 into R2. Now these two value that we will find out before, that these two value after multiplication that will again store in the which register, in R1 register. Now the final is we have the memory location what, X. So finally we have to put all the final value into register X. So move X R1. This operation means the value that will store in the R1 register after the multiplication of R1 and R2, that value will transfer into M of X. Means X is the destination address and M of X the memory location of the X, and it is the destination address, and finally our operation of two address instruction set is finally completed. Thank you.